Hi, welcome to this tutorial on arithmetic progressions. Now, what is an arithmetic progression? Well, what we've got here is a couple of sequences, and if you were to work out what the next term or two are in each of these sequences, I'd like to think that when you look at this one, you see that it goes up in even steps of 2. You can see that the difference between 8 and 6 is 2, and the same applies to the differences between 10 and 8 and 12 and 10. They're all going up by 2. We're adding 2, if you like, each term. So the next term would be 14, and the one after that 16, and so on. Whereas in this particular sequence, we're going down. We're going down by 3. We subtract 3. That's the difference between 8 and 11, minus 3. The same between 5 and 8, minus 3. And 2 and 5, minus 3. We've got this common difference all the time. Now, if ever you've got a sequence like these ones here, where you're going up by the same amount or down by the same amount, then it's called an arithmetic progression. Now, when we're going up, say in this example, by 2, we call this the common difference. So in this particular example, d would be 2. Whereas in this example, the common difference d is minus 3. And we also have other notation for arithmetic progressions. We always call the first term of the sequence the a term. And so in the first one, a is going to be 6. And in this particular sequence, a would be 11. Now, what I want to show you in general is a few formulas that we use for finding the nth term and the sum of the first n terms in an arithmetic progression. Now, in general, then, the first term of the sequence is a, as we've just seen here. And then to get the second term, I would need to add that common difference. And so for the second term, we would have a plus d. And for the third term, we need to add another d to this term. So that would be a plus 2d. And the fourth term would be a plus 3d, and so on. So the ninth term, for instance, would be a plus 8d. The 100th term would be a plus 99d, and so on. And so hopefully you can see that the nth term is going to be equal to a plus n minus 1 times the common difference d. And this is a formula that you should try and learn. Okay, so we'll just highlight that there. The nth term then is equal to a plus n minus 1d. So, if I had a sequence, let's just suppose we had for the sequence, let's say we had 5, 9, 13, 17, and so on. You can see that this is an arithmetic sequence, or arithmetic progression, because it goes up all the time by 4. So we've got a common difference of 4 and the first term is 5. Let's just write that here. A is 5 and the common difference d is 4. So for instance, if I wanted to find the 21st term in this particular sequence, then I need to set n equal to 21. So we have, according to the formula, a, which would be 5, plus n minus 1, so if n is 21, we're going to have 20 multiplied by the common difference, which is 4. And if you work that out, we've got 85. So the 21st term then, in this sequence, if we were to continue it on, would be 85. Now sometimes we want to work out what the sum of the first n terms are. So for instance, if I wanted to work out what the sum of the first 21 terms were in this particular sequence, then I want to find or have a simple way of doing it rather than having to write all the terms out and then just physically add them together. Well, there is a formula for this. It's called the sum of the first n terms, written S with a subscript n here. And it can be shown that this summation is equal to n over 2, the number of terms that you've got, divided by 2, all multiplied by twice the first term, plus n minus 1 times the common difference d. And there's also another formula that you can use as well. It is n over 2 times the first term plus the last term, which we'll call L. Now I've given you these formulas without any proof at all, but you need to learn them. But if you'd like to see a proof of this, and I would suggest that you look at the video, because some exam boards do ask you to prove this particular formula, then you can see that in one of my other videos. So let's just show you how this works. So let's just take this series here, okay? We've got 5, 9, 13, 17 and so on. Suppose I want to find then the sum of the first 21 terms. That would be S21. And if we use the first formula here, n would be 21, so that would be 21 over 2, all multiplied by twice the first term, so that would be 2 times 5, and then it's plus n minus 1 times the common difference. So if n is 21, n minus 1 is going to be 20, and the common difference is 4. That's the gap between each of the consecutive terms. And if we work this out, what you get is 945. Or we could use the formula here for working out the sum of 21 terms. We can use this particular formula because we know the last term, the 21st term. Here it is, here, 85. So we've got n over 2, so n would be 21 terms divided by 2, and then we multiply that by the first term, which we know is 5, plus the 21st term, the last term, which we now know is 85, and that's it. So 5 and 85 is 90, and 90 times 21 divided by 2 comes out at 945. So obviously both answers agreeing, and that hopefully shows you how we can find the sum of the first n terms. Well, that brings us now to the end of this particular video, where I hopefully have introduced you to the formulas that we use for finding the nth term and the sum of the first n terms of an arithmetic progression. Now in the videos that follow, I will be showing you one or two examples that use these ideas.